All right, I think we can begin. All right, working group, Node, Lifecycle. It's November 25th, 2025. This meeting is recorded, so please abide by the code of conduct. All right, to begin, are there any introductions? Would anyone like to introduce themselves? Go ahead,
Uh,
Jay. Excuse me.
Thank you so much. I'm not a regular here, though I started off in the beginning. Just wanted to introduce myself back again. I am Ajay. I'm currently with Google working largely on the Signode reliability aspects. Um, I, I have a topic that I want to get into later, but like I had a chance to like discuss with some of the folks on node lifecycle management from the working group at KubeCon, so very interested in engaging and continuing discussions here. I'll wait for other introductions before diving onto the topic. Nice to meet everyone here today. Thank you.
Great, thanks, Jay. Okay, anyone else would like to introduce themselves?
Yeah, I was at last week's one was my first one. I also had a good conversation at KubeCon and just trying to get a little bit more involved in Kubernetes open source. So really enjoying everything that has been going on in the discussions and excited to keep seeing more. And maybe at some future meeting I can share some of our use cases. Almost done going through all of the pre-recorded meetings, but yeah, it's great. Thank y'all.
Great, welcome. Jay, you said you're from Google. Matt, uh, where, what
Oh,
company?
yeah. Hey. I work at a company called Scale Out. My partner and I started to help companies do a bunch of cloud native engineering and digital transformation type of projects. So we've been in business for a few years now, and we've worked in all the major cloud providers doing other open source. Like my partner contributed to Istio, and I've done some small contributions to Grafana and some HashiCorp things, stuff like that. But haven't been super involved in the Kubernetes world, other than some pull requests that we had opened a while back for drain flags, which is why this particular uh, working group was so interesting. A bunch of our customers are kind of dealing with node lifecycle stuff. So yeah.
Cool. All right. Thanks, guys. All right. Anyone else for introductions? All right. If there's no one else, then I think we go to our first topic, which is yours, Jay,
Hey,
and node
sorry.
readiness control like this.
Uh,
Oh yeah, go ahead.
yeah, sorry. I'm not used to Zoom. I couldn't find the audio in the bottom left. Uh, this is my first time attending. I'm Dan Henneke. I met a lot of you guys at KubeCon. I'm at NVIDIA, and yeah, very interested in the node lifecycle stuff with a lot of the work we're doing with the GPUs and whatnot. So yeah, I'll probably just sit and listen the first one, but just wanted to say hi.
Awesome. Okay. All right. Anyone else? I'll give a longer pause this time. All right. Cool. All right. Thanks everyone for saying hi. All right, Ajay,
Thank
you're
you
up
so
first
much.
with node readiness. You should have
Um,
the ability to share your screen. I can
Thank you.
see if you can
Uh,
take it from me.
Got it. I'm trying to find mine. It's not okay. Sorry for the delay. It looks like I may have to like reopen Slack. It's having permission. Sorry about that. I've been a minute.
Okay. No problem.
Zoom is difficult sometimes.
I might have to give you host again, Jay. Oh, there he goes. Okay, I see your screen. I can't hear you though, Jay. We're almost there, halfway there.
Can you guys hear me now?
Yeah, there we go.
All right, sorry about the hiccups. It happens every time when I have to share. Uh, all right, so I wanted to quickly discuss over a problem that we have discussed during the beginning of this working group. It's about uh, how to bring out nodes readiness deterministically to the scheduler uh, more than or beyond the uh, like current ready state today. I think like this has been also discussed in the um, working group earlier, like I was also discussing with the folks during KubeCon, realized that like we understand or we acknowledge the problem that the current ready, which is a singular condition exported by kubelet, is not enough. And we are looking for more states or more layers of readiness on top to bring out the current state. In this case, it's workload readiness of the node that need to be exposed to kube scheduler. The kube schedulers should bind additional requirements or prerequisites before scheduling pods on the node. So that was a problem. I had a chance to discuss this in on conference session. And I also want to bring this up to this working group because it's of interest to a lot of larger folks here. Um, so this is the readiness gap we discussed earlier. Scheduler sees the green lights only based on kubelet's default um, ready state, which is basically just checks whether the container runtime is ready and whether the CNA config is present and whether a single container can be run at the node. So there have been some brittle workarounds in common in the industry, manual taint management by individual CNIs or some startup scripts where we hold on in a container, like explicitly watching some state on the node, or just hoping that restart policies will help eventually allowing the pod to start
Jay,
correctly.
can I interrupt you for 1 second? Would you be
Yeah.
able to shrink the presenter view? It's blocking
Oh,
some of the
okay.
slides.
All right.
You yeah, it's just kind of yeah. Thank you.
I wasn't sure like which screen I was presenting. Hope I'm able to get the slides corrected now. Okay. So this was initially discussed for a KEP to bring this into core Kubernetes, but we have realized slowly after the initial discussions that um, this need more uh, strengthening or more idea needs to be solidified by adopters before bringing this into a standard or before bringing this into the core Kubernetes as a accepted mechanism. And main problems were around how the components would export the conditions. Like what if a component fails to export? So there needs to be more flexibility around the control than baking it directly on the node object. So we realized like we could have this as a controller that can be an add-on that can be realized on top of Kubernetes cluster, so that like people will be able to manage this with CRDs more flexibly, like mapping conditions as they fit. And it also allows us to give more options like dry run, which is not possible if we make this as an API. So currently, we created this as a out-of-band controller. This is a Signode sponsored project that is evolving right now. We are looking to close some gaps, get feedbacks from working groups, and target initial release soon. The core idea is that like you create a rule object, you define what conditions are mandatory from a node to satisfy the prerequisites and map it to a taint so that like the controller will know what conditions it needs to expect from the node, and it would lift the taint on the node when the conditions are satisfied. So it is many-to-one mapping. A rule can have many conditions mapped to a single taint, and there can be many rules mapping to different groups of nodes. And the grouping of nodes is managed with a label selector, so that like you will be able to apply different selection mechanisms or different readiness requirements for different groups of nodes in your cluster. So it relies on existing standard Kubernetes constructs like the conditions or the status objects, like the node status conditions they have available today, and the update path from the node to the control plane. It can rely on existing components or existing flows like NPDs, which can post a status update just by pulling on a component, or it can be directly from the component itself, like in the case of CNI sum due today. So it will be less disruptive for onboarding.
Jay, there's a question from Matt.
Oops. Sorry, yeah. Sorry, I don't see the screen here. Please interrupt
Yeah.
me. Yeah.
I was just curious, does this end up with like a slight race condition because it's out of band, where like the node comes up and it says it's ready, and then this has to detect that and put the initial no schedule on it?
Yeah, that's a good question. So allow me to explain that. So this race condition is still possible because like the controller will have a watch delay.
Yeah.
So it is required in our like since it is out of band as we discussed, it is required for the nodes to start with the bootstrap for the initial readiness establishment, so that like the bootstrap taint aspect still exists. The taint management would just remove the taint once the conditions are established. And it can also be configured for continuous enablement. So if you have like a component upgrade, like a version upgrade you are managing, and you want to like put the node on a hold on a readiness flow, then it would be able to manage that, because like controller will continuously watch the condition and it will
But
manage the taint.
other than at that initial boot time, there's no real race. And then is it the job? I haven't gotten a chance to look through the code yet,
Mhm.
but I assume there's like a segregation of jobs where if that race condition happens and something happens to be scheduled on that node, it's not the readiness controller's job to like drain it, right? To like make it
Right.
empty again. It's going to be in whatever state it's going to be in.
Yeah,
Okay.
yeah, you're right. We discussed when we were discussing the KEP, we discussed about other actions like Cardin
Yeah.
for enforcing the readiness, but the taint management controller in its current shape only does scheduling control.
Cool.
Or if it doesn't, for example, like you can create a rule after some nodes are present, so it doesn't lift the already landed pods from a node, right? So it wouldn't manage the existing workloads.
Yep. Yeah, that makes sense. Great. Thanks.
Yeah. Okay. So the goal is to have a declarative control over nodes readiness. You want to specify what is important for you to be realized on the node before you can lay workloads on top of it. Here, this is an example where a simple node readiness rule object for ensuring the node's CNI is ready. Imagine you go on a cloud provider setup, you want to install a specific CNI, and this needs to be done before the user workloads or before your user workloads can be laden on the node. So this can be managed by, for example, like specifying a condition like Calico ready, and your NPD or like your sidecar running on the node, running on the workload could expose the CNI's health condition, uh, like and as like map the condition here and map it to this taint. For example, in this case, like readiness case.io network ready. This taint will be the one that would be used to control these conditions. So the controller would basically like would watch for this every node that's been started that in this mapping label. And once the Calico is installed and it is ready, it will lift the taint on it. So the API is, as we discussed here, this is a standard node label selection. In this case, like it is selected only on the worker nodes. In production scenario, I would expect that like there may be different platform nodes, and you may have, for example, uh, like a ML nodes, or it can be for a specific team, like a storage teams, storage array specific group of nodes. So the label selection for the uh, for for the uh, for the nodes here would be like the non-platform nodes. The controller would be installed on the platform nodes, which is a prerequisite we need to manage before using the readiness tools. And we also added an enforcement mode. We realized that some use cases, like for example, like some customers would want to update the kernel module on the node, like some customization that needs to be done on the nodes or some installation of VM agents. So it's done only at the bootstrap stage. So after the initial readiness is enforced, the controller will add an annotation on the node so that like any future restarts or anything uh, wouldn't put this back on the queue for readiness management in the controller. It's just a simple nicety that like controller wouldn't need to expect the condition updates from the node after the initial setup. There are also some other API. I discussed a dry run that is on the rule object. So when a rule is created in dry run, it will look for whether there are any nodes on the existing label group, and it will create dry run results on the status object. So it will be enabling the admins to understand the impact before the rule is created or updated. So yeah, this is the API as the minimalistic API that we see would fit for a simple readiness controlling mechanism to give the predictability that we are interested in. Are there any questions here that we can take before moving on?
Yeah. Have you thought about like the maybe like the rate at which these are being applied, these taints are being applied, or
Mhm.
considered that?
Are you, I think like looking about the scale, we expect that like it can be in order of up to like a 10 like components, for example, like can be scene installations, can be many other things on the installations on the node, like mostly by daemon sets. I think it can be up to like 10, maximum 15 components on the node. And we have been doing some minimal scale test. I was able to do up to 200 nodes without any delay, I mean, taint management delay. And I think that like there is this plan, like, I'm just like trying to find use cases now, but the goal is to have up to 2000 nodes with 10 components each node completed as a prerequisite for our release. Is that the scale or the rate um, use, you're discussing, or is there something else when you say rate?
Yeah, I guess I was kind of more alluding to like the current node lifecycle controller uh has like a essentially I think they call it like an eviction rate limiter.
Hmm.
Uh uh is that something we need to consider when adding the taints from this
Hmm.
controller as well? What are your
Um,
thoughts?
Yeah, we are looking to evolve this based on this because we use the queue builder, we use a basic rate limiter queue. I think like it may have some limitations, but we may have to basically like see how it fares in the school scale test and like the use cases and see if we need to handle more optimizations. But it uses the controller runtime framework today, and it uses the rate limiter queue for the work queue to manage the condition updates from the node. Um,
Okay.
and yeah, there are two paths here. One is a slow path, which is a rule creation, which I expect wouldn't be as frequent because the infrastructure readiness requirements doesn't change as frequent. However, the node updates or the creations of the fast path, that is the more frequent updates I need to watch out for. And we done some optimizations on the node. We will be caching the rule objects, and the node conditions updates will only be watched, not the all the status updates. So there are some optimizations handled for improving scale, but we need to basically like battle test this in production. We are having some use cases within Google that we are trying to also address this with this, in, like, within our systems as well. But yeah, like this is being done today.
I think the
Okay.
use case I wanted to add to, I think maybe the use case is that if you're providing this taint from a daemon set, and so if the daemon set pod is flapping, right, it's becoming ready, and it's like, hey, I'm good to go, and then 30 seconds later it's gone, or 10 seconds later, and then it comes back and back and forth, and the taint coming in and out.
Mhm.
I think that's how maybe I'd express the use cases. Like how we deal with those kinds of situations.
Got it. I think like one aspect we have in place, which is like a very crude way of handling it. We have like in the API like configuration to rule configuration to check whether it's been like enough time since the condition update. That's not the best way to handle that, but uh, like we have some minimal, for example, like the controller doesn't immediately like lift the taint. It just like waits for the condition of the edge to be stable before acting on it. So we have some basic setup there to protect it. I'm just looking for the CRD to show that. But yeah, there is some minimal support here. Wait time is one way to do it, but yeah, we're looking to understand like how much that affects, how much of this needs to be handled in the controller, or whether it has to be from the update flow, whether like a condition it's been some time before, like we can wait it from the other end. So yeah, that's something still one of the use cases we are looking to improve. Yeah, grace period is what we have today.
Okay, and from Philip.
Okay, so I see like you have two modes. One of them is bootstrap and one of them is continuous. So how does the node reboot fit in here? Like, do we expect like to be this under the continuous? I expect like the bootstrap will be just like when the node is provisioned, right?
Right. So when a node reboots, for example, in a maintenance setup, the bootstrap, the node object doesn't change. So if it's something that needs to be, for example, handled at every node reboot, then yeah, it has to be a continuous flow. Because, for example, some certain things like kernel module installation or something that's persisted on the node can be helped by bootstrap. But yeah, like if it is something that we expect to be present after every node reboot, it has to be a continuous.
Okay. And do you expect like adding other modes in the future?
Right now, we see only bootstrap only and continuous, but I think that like we want to find more use cases to see if anything more customized has to be handled up at the root level.
So
Do you have anything open on your mind like that you think?
just
Mhm.
asking in general. So your use cases are solved like by the bootstrap mode right now.
Mhm.
Okay, great. Thanks.
Yeah, yeah. Bootstrap is the default right now, but yeah, like if it is something um, else we need to support, we probably would need to look at the use cases. Are there any other questions?
Yeah, could you
Mhm.
talk a little bit more about the conditions here? Um,
Mhm.
like when this is like I kind of expected the conditions to be like an endpoint or some type of evaluation that would need to be run. And so when this just says like type and required status, I assume the
Mhm.
conditions are going to be reported in the node status. But like
Yeah.
how do they get there? And like when I look at this example, like what does this one I know what Calco is, right? But like
Mhm.
what does this one mean? Like how would that actually get set?
Yeah, sure. So in this case, like I have a demo later as well, but in this case, um, I want to watch the component's health endpoint and export that because it's a critical pod. This critical pod's readiness uh, will translate to the node's readiness as well. So,
Yeah, and I guess so that's the
right.
part where I was
Mhm.
like a little surprised. Like when this says type,
Mhm.
what is this actually polling?
Right. So the controller doesn't directly hold the component. For custom conditions like given by the user, the
Mhm.
users would have more knowledge about. For example, it can be we discussed the NPD flow, right? It can be like some script run by a custom plugin on the node to check, for example, like a module readiness or a driver readiness, and export that as a node's status condition. So it can be an
Okay,
NPD,
so
like an
yeah, so
yeah,
ultimately this would be the responsibility of, in this case, Calico, to
exactly,
actually set this condition on the node.
right.
And
So one,
whatever other, okay.
yeah,
So, and this condition is basically just like it's just a label essentially, and it would have to be equal to true in this case.
yeah. So
Right.
one pattern we are seeing evolving in Kubernetes is that there is a cap that was targeted for 1.35, but I think it slipped the deadline. But one pattern we see this is like exposing pods information locally on the node to daemons to be able to subscribe to various statuses, and readiness is one of the state. And we see like a natural evolution where like NPD could stream for pod readiness events on the node. We are discussing this as an improvement. So whenever the CNI ready happens, this could be like watched by the NPD or another agent on the node. For example, it could be like a and like GPD GPU specific service or something that daemon running on the node that has the responsibility to gives a device status. And this condition now needs for certain conditions that need to be perceived as nodes conditions, they can now be translated to a node's critical readiness condition. So this is how we see like the conditions can be mapped uh, at a node level, and they can be used to manage uh, readiness stains on the node.
That makes sense.
Yeah,
So basically then the job of the readiness controller is really just monitoring for
yeah,
these conditions, and there's some polling interval and controlling the taint that's specified in the gate rule.
right, exactly.
Great. And enforcement mode in this case is when this will be evaluated. Like I know in the README you mentioned that like after bootstrapping, the node will be notified that like, hey, this has been be annotated somehow that bootstrapping has been completed, and it won't watch these things anymore. What are some other enforcement modes that are available?
Yeah, so there are only two enforcement modes right now. One is a bootstrap only, which basically would only during the initial node create time, we are basically watching on the node create and updates. And when a node object gets created, the controller reconciler will basically like look for the conditions, map the conditions on the taint. It will check whether an annotation is present. If bootstrap already is completed, it will skip the node because it's already handled by it. The other is continuous, where it will try to enforce it at every update time, so that like if a condition flips, it knows that like okay, it doesn't match the required status, and I need to reinforce the taint. Where we can also check a grace period, as we discussed. But continuous is where it will try to lift all the conditions as unlogic as listed in the rule, and try to see if all of them are satisfied to manage taint.
And is enforcement mode immutable for the readiness gate rule, or could you change it after the fact?
Um, Currently, we have it as a modifiable aspect, but I
Okay.
think like in the case of enforcement, the annotation is already added on the node. So yeah, I think like it cannot be moved back from continuous to
Okay.
bootstrap to continuous. Maybe that's something we can check, but I can think of use cases where it may be
Yeah.
needed. Yeah.
Yeah, I was just curious. All right.
Right.
Awesome. That makes sense.
One aspect while we are here, I could also discuss here is that like misconfigurations can happen. So to also, for example, give more flexibility to the admin, the delete flow is also implemented. So if a rule is deleted or modified, like to remove a condition, the rule object will be reevaluated by the node, and the nodes, for example, if a label is changed, uh, nodes that are not matching the label right now will be removed of the managed taint. So the map retained no longer applies on the node. So if it's present, it will remove it. So that's something we added there. Like we get feedback on how it fits the use cases, but we see that it is also important to make sure that like we are not going into a maintenance action where the admin has to manually patch 100 nodes to manage this configuration. Yeah. So as I discussed, this has like in a high level two loops inside, one watching the node and the other watching the rule creations. Rule creations can happen after the node as well. So to support that, we have a dry run mode. So the evaluation is simple. Whenever a node is created, it see if it matches uh, node selection, node selection based on the labels, and it will look for the mapped conditions in the rule object and updates the uh, node spec for taint if needed. And as soon as like we have some node evaluations done, the rule status object is also updated to make it more visible for the admin on the manager nodes at the rule level as well. So this is the high level flow. Like I said, like I tested it with up to 200 nodes. There hasn't been any taint management delay. I think that we would want to see if there is any scalability improvements, especially the update flow. Like there was a concern on latency. Like if a component is ready, for example, NPD updating the ready status to the controller can have some delay, and also the update to get to the node can have some delay, but this is very minimal in the order of seconds. So this latency concern, I think, can be improved by, as we discussed, like a node local API that is coming up in Kubernetes as a pattern. This would make us more an instantaneous update from the node as soon as it is ready. But there are some more improvements that I think uh, we are looking to add and see if it can apply to like latency critical use cases as well. Um, some of the use cases we discussed, one is CNI ready, as we also discussed earlier. We also presented this to SIG storage. One of the use cases is where the storage capacity can take some time. For example, AWS initializes the volumes to be infinity. So if workloads were assigned with more volume than the node can provide, now it's like a maintenance problem where you need to reschedule the pod because the the scheduler will take some time for getting the capacity visibility. So this is another use case on storage that for those drivers that would need some time for the capacity to be rightly set, especially in auto scaling scenarios, it would save some money if a readiness control mechanism can be utilized. And for specialized hardware case, for example, infinity band setup or GPU driver installation or DRA driver installation, it would take some time, like in order of minutes before the node can be ready to handle the user workloads. There are more use cases like checkpoints and restart path need to be fully done to enable fast to ensure that the fast readiness for the workload like the pod runtime. So those use cases would best fit with um, readiness controller as well. And other things things like complaints requirements, like security daemons, ensure that like all the started user workloads are in the expected compliant state can also be ensured. So these are the use cases we see would best fit. We are trying to talk to folks on like how readiness controller helps the cases. I have a quick demo, but I want to hear for people's questions before we go on to more. Is there any questions I can answer first?
Yeah. So like you said, like you do not expect to support like the no execute taints, right?
So the API in its current shape allows the user to because the effect is flexible. If they specify no execute, this is possible. This is supported today. But I wonder like if this when it comes to core Kubernetes mechanism, I'm not sure like how that would be, but there is no restriction today for the node readiness controller to add a no execute taint.
Okay,
this
so
is
sorry,
possible
so
today.
I misheard. I thought like it's not supported. So like since it is supported, and especially like in the continuous mode, like we can expect like that the workloads that are running on these nodes like do not like manage or have like the tolerations they would need. So this has like a big potential to be like disruptive to all
Yeah.
the running workloads there. So I guess like I would just like to advise like to be careful with the no
Mm,
execute support.
got it. Yeah. I think one one integration pattern I could see is a descheduler project, which could basically like select workloads that need to be moved away, than handling with a no execute taint. But yeah, that will give more like flexibility on the configurations. I see your like concern. It probably would need to a documentation on the project that there is some risk adding a no execute taint because it would be like disruptive to the existing running parts of the node. I agree.
Yeah, it seems to me like like difficult to implement like in the descheduler because like selecting it's hard to select the workloads with taints and tolerations.
Mm-hmm.
Yeah, I wonder like if you have like use cases that would use this, like if it makes sense to like disable it until you have like all the flows figured out because this also I mean like the thing is like you have to think about like what happens like when the node is running and everything is
Mm-hmm.
correct. And then it's also like the termination part, like where like we have this problem like with the graceful node shutdown, and you basically have to order the workloads correctly to leave the node. So
Mm-hmm.
I like you would basically run into the same or similar problem that's like might be hard to solve.
Mm-hmm. Yeah, if you get a concern, the no execute specifically, it could be risky because of the disruption aspect. I think I'm not familiar whether the no execute will bite the uh, the graceful timeout as well. But I think one area where at least like descheduler where I see it could be useful is that if this workloads certain group workloads could be moved to some other nodes where the state can be continued or it can be like restored and running. It would be non-disruptive, especially for like training workloads where we see that people try to maintain a buffer of nodes and individual node disruptions like are more expensive if the whole group of workloads need to be parsed, right? If this can be like moved, for example, without needing for the whole workload to be restarted, would still be beneficial, I think. But yeah, we don't know like how disruptive we don't have like use cases where people tried this on yet, but
Yes,
maybe we
so
need to, yeah.
yeah, sorry. So I mean, like the migration aspect of workloads is not
Mhm.
like easy to solve. Like,
Right.
like we tried to do that like with the eviction request cap we have,
Mm-hmm.
and even though like you have like some period of time like before the taint kicks in, and then you have
Mm-hmm.
also the graceful termination seconds, like
Mm-hmm.
it's still like we see like in like under like systems like people have that
Mm-hmm.
some workloads might take hours or days to leave the node. So
Mm-hmm.
like I expect like if you enable this feature or like the no
Mm-hmm.
execute, then
Mm-hmm.
like this might like hinder some of the use cases.
Got it. Got it.
And yeah, sorry to just
Yeah.
follow up, and like to small extent this is also true like with the no schedule, because you can have like a disruption from different vectors than your controller. And when this
Mm-hmm.
disruption happens, then it's not possible to schedule it again, even if it should be scheduled. So, but that's more minor issue, but it's still existing. But the no execute one, I think, is yeah. And like,
Mm-hmm.
do you have like use cases for the continuous mode?
One aspect where we heard about people wanting this is the security daemon installation, where the policy needs to be like changed or the security daemon needs to be upgraded, where like a pod that's falling in between this window could go into could risk non-compliance, right? That's one use case that I have had where continuous mode is needed. But again, it may be something out of this that I mean I haven't explored more use cases. Yeah, yeah.
Yeah, so then like you are basically running into like the permission issue, like like
Yeah.
which kind of workloads, like like the security daemon should be above everything else, or
Mm.
some of the workloads are maybe like high critical priority and they should be running even though security daemon says no. So yeah, I see like a yes couple of
Mhm.
these issues.
Right. I think just blocking with no schedule helps. Like even in continuous mode, because like existing pods that are running, they're expected to be already compliant, because like they had this uh, like condition imposed. I don't see the part where you mentioned like no schedule. You could see problematic with multiple controllers. Could you maybe clarify that again?
So you
Uh,
mean no schedule in continuous mode?
yeah, you said like that something can be problematic. Could you clarify that?
So like if you have like a other disruption from like other vector, so I don't know, like from the like kubelet itself or some other thing that is not managed by you, or for example the scheduler.
Mm-hmm.
And um, but I mean, but like the pod could be disrupted, but then it might like want to return back to the node. So for example, for some daemon, like if it was disrupted in like in a way that's because maybe it has a low priority or something, it was preempted, and then
Mm-hmm.
it might want to run again on the node. So then like the node schedule would block running such a pod.
Mm-hmm. So if I hear correctly, the preemption could, for example, boot out one of the required component. So that means that the conditions are not satisfied and the taint is added on the node. So other workloads could not be assigned on the node, because like the expected pod is not running on the node, right? I think that I see the scenario, but I think that like then we are we are breaking the declared rule, right? Like you want certain components to be ready, so a component that is preempted is not a desired place as well. So yeah, I think like it may be some cases where like holding on to like that state, like blocked because like something expected is not on the node, maybe desired, but yeah, like maybe something more we need to watch out for and see how people use this and configure this.
Yeah, I mean, I like for like firstly, I think like the biggest issue is still like the no execute one.
Yeah. Mhm.
But like I see like this could like be useful for folks. But I mean,
Mm.
we are uh, like basically expecting like the workloads and like everything to be set up correctly. So like, if you have everything set up correctly and every workload knows like what to expect during each of these
Right.
taints or what kind of components, or they are aware that like the security
Right.
controller could disrupt them, then it's fine. But like if you want like if some components are not aware of this, like that's like where like issues could come up.
Hmm. Yeah. One thing I agree is that like we expect this to be used for infrastructure requirements, where the admin has an understanding of like what are the um, prerequisites on the node that needs to be managed, so that like the rule creation is handled ahead and the corresponding daemon sets are tolerated. And like you said, like this could work for the critical cases where the things are expected to be ready and they need to be like present before starting. Maybe some more flexibility we could think of, like how we could add to the mechanism if need to be opened for more use cases where it can be tricky. One use case, I think like one discussion we had from KubeCon as well was like, if a later new readiness requirement comes in, now the existing daemon sets need to be added for the toleration, right? So how do we manage that is like just create an issue on the project where we can have like a um, daemon set based toleration. Like if the owner references daemon set, inject the tolerations on the node object so that like all the daemon sets are treated as prerequisites. Or for example, it could be like managed with the specific prefixes where, for example, network has a prefix, networking team has readiness gates.io/network. And now you have like all this storage daemon sets have like a prefixed um, toleration added. Like prefix toleration is not present yet, but I see there is already a cap open on that. Like probably we could have a discussions on the use cases where it could benefit from this and see. Like I mean, the corner cases where the cases which we see are tricky, there is room for improvement in the larger ecosystem. Some of them we can provide, some of them I think uh, can actually come in Kubernetes, I think.
So I guess like the main value is for like critical components to
Yeah,
have
critical components. Yes.
to have basically synchronization between them and like
Yeah.
and they manage like the tolerations for themselves. So yeah, that's great. Yeah, I was just mentioning these things like to look out like in the future how people are
Got it.
using your project and
Yeah.
like if it like starts getting into these corner cases.
Right.
Yeah.
Thanks, Felipe. I definitely will add a caveat about the no execute. That is to watch out for.
Okay, cool. Thanks.
Yeah. Yeah, I think like we discussed the improvements that like we are seeing the low latency path, regex based tolerations that's already kept existing. And like we are also looking to have standardized prefixes. Some of them can be reserved, for example, core system. Some prefixes can be reserved for the Kubernetes, like core mechanisms, if need be in the future. So that's something we see we can do as improvements. And we are looking for the initial release sometime sooner after getting the initial concerns addressed. Time for a quick demo if we have time. I think it's 10 minutes. Maybe we could quickly go over this. I don't know if people can see this. So I just try to install on an existing kind cluster. This has like 3 nodes. The kind cluster has one control plane node, one platform node, which is labeled the result for platform. And there is another node where we expect the uh, Calico CNI needs to be installed. The kind clusters come with the default CNI. This is similar to a use case where uh, users would want to run, for example, enhanced CNI for their purpose or some other infrastructure component to customize them for their needs. So installing the controller, it's mapped to the platform with labels. And this is a readiness gate rule I'm creating. It's expecting to see Calico ready condition on the node. And whenever this is ready, only after then the workloads need to be allowed to run on their own. So it would manage this contain readiness gates.io network ready, and it would map it only on the worker nodes. So it having matching expression not to block control plane nodes, for example. And yes. So here I ran this installation and I see that like the controller is up. And then I try to show this is how the status will show. It shows a node evaluation currently has like one worker that is managed, which is the one that is non-platform or non-controller node. It is managed by this controller and with a stain. It shows the condition is not yet present. Status is unknown. And we try to see how it works. We're trying to create an Nginx deployment. So this has to land on the node only after the Calico is installed. So I'm trying to install Calico here. You see that like the Nginx is pending while things are getting ready. So this is a sidecar. It just check the health condition of the Calico component, which is at 9099 endpoint, and it is exporting that as a Calico ready condition. So this is the installation script for the Calico I have here. It just applies the daemon set and the sidecar. So once you see here on the left, once the condition is available, the Calico ready is landed on the node, the taint is removed by the controller, and the Nginx is started. This shows also the permissions on the right. The RBAC needed for this is node status patch and update, so the controller could patch the this is for the sidecar to be able to patch the status. The controller will have the node update permissions because it needs to also manage the taint. So then I tried to scale up the nodes so that like we'll be able to watch what if new nodes come in. So I scaled up the deployments and I'm also using a script to scale up the nodes. This basically simply creates new nodes, new containers, new Docker containers for worker nodes. You see here, the new nodes are shown on the left. The test worker 3 is not yet ready. It has the taint readiness case.io network ready, which is the one managed by the controller. And as soon as the Calico is ready, it will remove the taint. See here that like the condition Calico ready once as soon as it is on, the taint is removed and the Nginx is back on the node. It's posted on the node. That's all I have. If you see on the status object, it shows the node evaluations on what's the current status and the required status and whether they are satisfied. This is how I think like it can be observable by the admin on how the controller upholds the readiness requirements. Yeah, that's all I have for today. If there is any questions, I think we can have them.
Thanks, Jay. Looks like
Hi.
there's no more questions. Good discussion.
Thank you so much, folks. I have a Slack channel on this, and please also watch out for the project for updates. If there is anything, happy to discuss a use case or like to collaborate on getting this project to where it can be. Thank you so much.
Great. Thank you.
Thanks.
All right, I'm going to grab the screen back. So we've got 4 minutes. Okay. Working group at the US Maintainer Summit. So at the last KubeCon. Philip, did you add this one?
Yeah, just to like announce if people wanna watch it. So we basically introduced our working group and dove a bit into the pod and node lifecycle and like the caps we have opened. So the eviction request and the non-maintenance cap, and yeah, so like if you want to take a look, it's available. And also Doug from Uber like created a new repo for the eviction controller, which is like an experimental version of the eviction request controller. So like this is still like very early phase. So it's like a lot of things are still not implemented there, and the API itself will have changes. So like our next step is to update the cap. And but yeah, you can take a look at the eviction controller if you want to play with that. If you have like some interceptor that you would like to try out, like you can do that with this project. So it's nice to have it for playing around with that.
Okay. Awesome. Thanks. Okay. I think there's no more topics. I think we can we'll leave it at that. All right. Thank you, everybody.
Thanks,
Have a
everyone.
good day.
Thanks.
Hey.
Bye.
Bye.
Bye-bye.